Hi everyone, we will solve GATE 2012 Aerospace Engineering question number 46. Consider a high Earth orbiting satellite of angular momentum per unit mass h vector and eccentricity e. The mass of Earth is m and g is universal constant. The distance between the satellite center of mass and Earth's center of mass is r. The true anomaly is theta. The phase angle is 0. Which of the following statement is or are true? A. Trajectory equation is r equal to r theta equal to h magnitude of h vector upon gm 1 plus e cos theta. Option B. Trajectory equation is r equal to r theta equal to magnitude of h vector square upon gm upon 1 plus e cos theta. C. H vector is conserved. D. The sum of potential energy and kinetic energy of satellites is conserved. This problem is related to Kepler's law. So to know more about this Kepler's law and two-body problem, you can refer to this NPTEL video. So first we will start with the two-body problem. In two-body problem, there are two bodies of mass m1 and m2, and position of mass m2 with respect to mass m1 is r vector, which is position vector, and this position vector makes an angle theta with eccentricity vector e. This theta is also called true anomaly. When this theta is 0, then the position of mass m2 is called the periapsis, and the line joining the mass m1 and periapsis is called epsilon. Mass m2 has the velocity of r dot vector, which is also called v vector, velocity vector, and it can be resolved in two directions. One is tangential to the path of the motion, or second one is the radial direction. And the angle between velocity vector and tangential velocity vector is called the right path angle. So according to Newton's second law of motion, we can write r double dot equal to minus mu upon r cube r vector, where mu is gravitational constant of mass m1 and r is the position vector. This mu is equal to g into m1. If we solve this equation, we will get r equal to h square upon mu 1 plus e cos theta. We can also find the velocity. Tangential velocity will equal to mu upon h 1 plus e cos theta, and radial velocity mu upon h e sin theta. From the energy law, we can get the sum of kinetic energy and potential energy is constant. So if we put the value of velocity and position at the periapsis, we will get this epsilon equal to epsilon p vp square upon 2 minus mu upon rp, which will be equal to this if we put the value of vp. Vp will be nothing but it will equal to tangential velocity only. So it will be velocity at theta equal to 0. So ultimately we will get equal to minus 1 by 2 mu square upon h square 1 minus e square. So now if you see this problem, we have there are 4 options, and option A and B, only one option is possible, and we have to see if F and C and D are correct. So according to Kepler's law, this angular momentum is conserved always, so option C is correct. And we have seen that sum of potential energy and kinetic energy is constant in two-body problem, so this option D is also correct. And the equation of trajectory we have seen is r equal to h square upon mu 1 upon e cos theta, which can also be written as r h square upon gm 1 plus E cos theta. M is mass M1. So which is option B. So this option B is also correct. So there are totally 3 options are correct, B, C and D. This is the answer. Thank you.